We have page 244, question number 48, and this is actually a multi-step problem, probably meaning this will be one of the harder ones because you have to get so many right in a row and use one piece of information after another. Part A asks if this is an ideal machine and Stan was applying an effort force, what would it be? Well, IMA, the ideal mechanical advantage, is equal to the distance of effort over the distance of resistance. I'm drawing this in brown because the effort distance is going to be 20 and the distance of resistance is going to be 5, meaning the IMA in this machine is 4. So what that really means is it's going to make him 4 times, I don't say more powerful, but it's going to actually make it seem like the piano weighs 4 times less. So right now, if the piano weighs 1,200 newtons, the answer to A would be that he would be lifting with 300 newtons. So that's the answer to A. Part B said, what force is used to balance the friction force if actual is 340? So B now starts to say, okay, in reality, because there's friction in the system between the rope and the pulleys and so on, if we really use 340, ideally we'd only need 300, well then there's 40 newtons of friction force that need to be balanced out. Part C asks, what is the work output? And the output work is what actually happens. If we lift it 1,200 newtons, there's the force, 1,200 newtons is our resistance force, times 5, the resistance distance, all dealing with the actual weight right here, the work out is 6,000 joules. And remember, work will change energy. If we were to drop the piano, it would come down with an energy of 6,000 joules. D is asking what is the input work. Now, no machine is 100% efficient, so Stan here is going to do a little more work than what it takes to actually get out of it, and we would take the 340, excuse me, that's not picking that up very well, let me try this again, 340, there we go, times the 20 meters, and I did a poor job of showing he had to pull a lot of rope to get 5 meters of distance. The answer would be 6,800 joules. Finally, part E asks, if this machine had all of these stats, what would the actual mechanical advantage be? And I'm running out of room here, so I'm going to try my best. MA, try that again, MA is equal to the resistance force divided by the effort force. And that would be 1,200 newtons of resistance, or weight, and then he put in 340 newtons of force to balance out friction and the force he needed to lift. Newtons cancels. Remember, there's never a label on the mechanical advantage, and sorry this got so sloppy. Next time I shouldn't draw so big right away. We've got 3.53 as the mechanical advantage. If we compare mechanical advantage to the ideal mechanical advantage, you should notice that mechanical advantage should always be less than the IMA. Okay? It should always be less than, and that's a great way to check if you did your work correctly.